Associates Incorporation UV exposure system. This system is currently configured for a 500 watt UV lamp. This lamp housing can also be used for 1000 watt lamp. So right now for 500 watt lamp, an adapter is used on the cathode in order to adapt it to the 500 watts lamp. So for a 1000 watt lamp, that brass adapter has to be removed. And the power supply that is used on this machine is made by Radiation Power Systems, model 2105C2. So the operation of the lamp housing here is controlled by the timer, digital timer. The timings are adjustable. So I'm going to measure the energy levels at 365 nanometers, which is about 32.4 milliwatt per centimeter square. And at 405 nanometer, it is about 61.0 milliwatt per centimeter square. Now, at any point of time, if a lamp is changed, so there are 3 knobs in this top hood assembly. So the center knob is for adjusting the Z height of the lamp, and these two give an X and Y axis moment. So whenever the lamp is changed or if a new lamp is installed, a slight adjustment of these knobs may be required. Also, by adjusting these X and Y knobs, we can get a uniformity level finely peaked up. So I'm now adjusting the Z height and showing how the energy changes. So it is peaking up. So it is almost 64 milliwatts per centimeter square and 33.8 milliwatt per centimeter square at 405 and 365 nanometers respectively. So no attempt should be made to open the bottom covers because the lamp power supply is interlocked. The lamp power supply has a detector signal connected in and the interlock 4-pin connector here, and this is the lamp electrode connector, anode on the top, cathode on the bottom. The green lead is here, the yellow green is the ground. The lamp housing needs to be connected to a 4-inch dia exhaust connection, vacuum suction. There is a sensor here that senses that the exhaust is connected. Without the exhaust connection, the lamp power supply won't start. In constant intensity mode. So when known amount of UV energy exposure is desired, so we can operate in constant intensity mode. In constant intensity mode, the power supply will compensate for the decrease in UV light intensity levels due to aging. So it should be normally operated at about 450 watts constant power mode, and during idle we can decrease the power to 425 watts so that the lamp life can be extended. So this power supply should never be left on overnight, just in case if the exhaust fails or something. So for the constant intensity mode to work, this slide switch has to be moved to the constant intensity mode and select constant intensity. And there are 2 channels here, so each wavelength sensor can be calibrated. There is a dual detector inside. By using the cal part, we can, right now we have to read it as intensity. So this is a meter that indicates both power as well as intensity. And for channel B, I have so I'm able to change the intensity level. So right now it is at about 70 milliwatt per centimeter square intensity. I'm taking the outer scale, and you can see the lamp power is almost 500 watts. So if I change it to channel A, so you see a different set point. So this is at about 30 milliwatt per centimeter square. This 365 nanometer detector is calibrated here. So I'm going to set it at about 40 milliwatt per centimeter square. So this is the calibration and set point is for operators' convenience only. So the actual UV intensity is to be at the exposure plane is to be monitored using external detectors. So it's important to notice that both the wavelengths are available at the exposure plane. In case a single wavelength is to be used, then additional filters have to be placed in the path of the beam. Watt lamp power supply is used. With a 1000-watt lamp installed, the power supply has to be a 1000-watt power supply, and these are the connectors normally on the 1000-watt lamp power supply. I'm going to demonstrate how to access the lamp. The unit will be usually shipped with the lamp taken out. So this is the 45 degrees mirror. There is a small clamp underneath, so you rotate it and then the mirror goes out of the way. And so first make sure the power supply is turned off and the lamp is sufficiently cooled, at least half an hour. And then first, using powder-free gloves, remove the thumb screw on the electrode, and then remove the braided electrode wire and the heat sink. After that, gently rotate the lamp clockwise. So the lamp comes out easy. So at the time of installation, again, make sure that the anode, which is marked anode down, it should be down, and the cathode goes up. So in case if the the lamp electrode is not visible, it's possible to view the lamp electrode by removing the exhaust gas connection, or else by practice it's easy to get the lamp into the lamp electrode. If necessary, the back panel can be opened to access the lamp electrode. Viewing through this side, we have to connect the. So this heat sink goes on the electrode first while installing the lamp, and then the braided wire, which is this one, and just fingers tight is good enough. Over tightening could lead to the ceramic paste on the electrode connections to break, and the lamp becomes not usable anymore. So after connecting the lamp, lift the 45 degrees mirror like that. This is a cold mirror or a dichroic reflector which reflects the desired wavelengths, both 365 and 405 nanometers. And the shutter is behind this plate here. On the other side, there is also a light integrator lens here, and this is the switch which is connected in series with the interlock for the power supply to turn on. If this door is open, the lamp power supply cannot be turned on. And exposure to UV should be avoided, and always use UV protection goggles while handling this system.